With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, the question is density of dry air containing only N2 and O2 is 1.15 gram per liter at 740 mm of Hg and 300 Kelvin of temperature. So what is percent composition of N2 by mass in the air? So in this question we have given that density of dry air containing only nitrogen and oxygen gas and density is 1.15 gram per liter at the pressure of 740 mm of Hg and temperature 300 Kelvin. Now we have to find out the percentage composition of N2 by mass in the air, right? So let's start. So basically we have given the pressure 740 mm of Hg, right? And we know that 1 atmosphere is equals to the 760 mm of Hg. So basically we will convert this temperature into atmosphere. So it will be P is equals to 740 mm of Hg divided by the 760 mm of Hg. And after solving this we will get 0.97 atmosphere, right? And we have also given the temperature which is already in the Kelvin, that is 300 Kelvin, right? Now moving forward, we know that ideal gas equation is PV is equals to nRT, right? Where P is the pressure exerted by the gas, V is the volume occupied by the gas, N is the number of moles of the gas, R is the universal gas constant, and T is the absolute temperature of the gas, right? Now for 1 mole of gas, the ideal gas equation will be PV is equals to RT, right? Now we know that density is nothing but mass per unit volume, right? So from here we can write it as volume is equals to the mass by density, and we will use this expression in this ideal gas equation. So now the ideal gas equation will be P into mass by density is equals to the RT. In this expression, this mass is the mass of the mixture of dry air containing only N2 and O2, right? Now from here, mass of mixture will equal to the dRT by P, right? Now let's start putting the values. So value of density is 1.15 gram per liter into value of R 0.0821 atmosphere liter per Kelvin per mole into 300 Kelvin divided by 0.97 atmosphere, right? And after solving this, what we'll get? We will get the mass of the mixture is equals to the 29.09 grams. Now this mixture of mass is equals to the molar mass of nitrogen into mole fraction of N2 plus molar mass of O2 into mole fraction of O2. And we know that overall composition of mole fraction of N2 plus mole fraction of O2 will equal to the 1, right? Now moving forward. So after this we will consider two cases. So first case will be when mole fraction of N2 will equal to the 1 minus mole fraction of O2, and we will use this expression here. So mass of mixture is equals to the 28 into 1 minus mole fraction of O2 plus 32 into mole fraction of O2, and after solving this we will get 29.09 is equals to the 28 minus 28 into mole fraction of O2 plus 32 into mole fraction of O2, and from here the value of mole fraction will come, that is 0.2725, right? Now therefore percentage composition of O2 in the mixture will be mole fraction of O2 into its molecular mass divided by the mass of the mixture into 100, right? Now let's put the values. So mole fraction of O2 is 0.2725 into its molecular mass, that is 32, divided by the mass of the mixture, that is 29.09 into 100, and after solving this we will get 29.97%, right? Now moving to the second case. So in second case mole fraction of O2 will equal to the 1 minus mole fraction of N2. So mass of the mixture will equal to the 28 into mole fraction of N2 plus 32 into 1 minus mole fraction of N2, right? And after solving this we will get 29.09 is equals to the 28 into mole fraction of N2 plus 32 minus 32 into mole fraction of N2, and from here the value of mole fraction of N2 will be 0.7275, right? Now percentage composition of N2 in the mixture will be mole fraction of N2 into its molecular mass divided by the mass of the mixture into 100, and after putting the values we will get 0.7275 into 28 divided by the 29.09 into 100, and after solving this we will get 70.02%. So this is the percentage composition of N2 in the mixture, and this one is the percentage composition of O2 in the mixture. So therefore the percentage composition of N2 by mass in the air is 70.02%, and also the percentage composition of O2 by mass in the air is 29.97%. Now coming to the options. So out of these four options, the only option which is near to the found values is option 1, that is 82.5% of N2 is nearest to the 70.02, and 17.5% of O2 is nearest to the 29.97% of O2. So option 1 is the correct answer. So this is the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.